All right, the second part of the day is permutations. And permutations is a way to count objects when order matters. All right, for instance, if we look off to the side here, we're finding the different outcomes where we can order A, B, and C. All right, if we look, there's obviously 6 ways to figure this out. Another way to think about this is very similar to the way we counted our license plates. But keep in mind, once we use the letter, we can't use it again. So we have A, B, and C we could put in the first spot. After that, we can't use the letter again, so there's only 2 options for the second. After we've used 2 of our 3 options, there's only 1 for the third. Just like before with our counting principle, we want to multiply the outcomes together, and we get a total of 6 ways to order the 3 letters A, B, and C. This can be shortened up using our math factorial symbol, which is an exclamation point, and essentially this means we take our number and we multiply all the way down to 1. So 3 times 2 times 1 equals 3 factorial, which also equals 6. And that's what this box describes for you. All right? So we'll zoom in a smidge here as we look at different options. All right? How many ways can we arrange the first 5 letters of the alphabet? Well, we could write this like we did above, or our understanding is now we could just do 5 factorial. We're not going to have repeated letters, so there's 5 options for the first, 4 for the second, 3 for the third, 2 for the fourth, and 1 for the last spot. What is 5 factorial? 120. You may be able to find this button. It's on your calculator. If you go to the math menu, you want to arrow over to probability, PRB, along the top. Your factorial key, I believe, is the 4th one down. Okay. On part B, how many ways can we arrange the first 5 letters of the alphabet if the vowels must be placed next to each other? So when we're thinking about this situation here, our vowels must be placed next to each other. We have A, B, C, D, and E. We have 2 vowels and 3 consonants. So if we look at this, we know A and E must be placed together. Okay? So we essentially have 4 letters and a group of vowels, or 3 letters and a group of vowels, which is 4 objects. So we have 4 factorial ways to arrange those. But then keep in mind our vowels we can arrange in 2 factorial ways. So 4 times 3 times 2 is 24, times 2 times 1 is 48 ways. So there are 48 ways to group these 5 letters, assuming the vowels are grouped together. Keep in mind that's different, and that's less than the vowels, or just the letters itself, as we did in part A, because our vowels have to be grouped together. There's a restriction there that's going to limit the total number of outcomes. All right, very similar, looking at part B. How many ways can 16 horses in the Kentucky Derby finish first, second, and third? Well, this time we're not looking at all the objects, we're only looking at the first 3 positions. 16 horses have the option to finish in first place. After they finish in first, we know there's only 15 that could finish in second place, because you can't have a horse that finishes first and second and third. So each time we go down by 1, notice we only care about 3 spots. All right, and if we multiply those together, we get 3,360 different ways. This takes us directly into our permutation notation. If we want to look at it in terms of that, we have 16 objects. We care about order, and we're looking at 3 spots. If I were to calculate this, coincidentally, we get the exact same result, 3,360. You could find that button on your calculator again under the math menu, arrow over to probability, and I believe permutations is the 2nd one down. All right. As we continue on, we're looking at just simple notation here as we go through things. So as you do these, we just want to see that you understand what this means. So when you see 7 factorial, that means 7 times 6 times 5 times 4 times 3 times 2 times 1. Write that out so we actually know you know what that means versus just typing it in your calculator. When we have a problem that's a little more significant, where we have this notation, we know there's 10 objects and we care about 4 spots. So it's really similar to the horse question up above. We start with 10 objects, and we go out 4 spots, is what it would work out to be. We wind up with 5,040 different options here. We can use the same mentality, even with algebraic notation. N minus 2 is where we start, and we go out 3 spots. Some of you might be wondering right now why I said n minus 3, n minus 4. Well, if I subtract a bigger number each time, the number is getting smaller overall. Okay, n minus 2, n minus 3, n minus 4. Example, if I typed in, if n was 10, 10 minus 2 is 8, 10 minus 3 is 7, 10 minus 4 is 6. So you notice as we continually subtract a larger number, the numbers are actually getting smaller in the long run. So this is how your problem would look algebraically. All right. The last thing we're looking at is distinguishable permutations. Sometimes we have options that we can't tell the difference between. So we have 2 A's, we have 2 L's. These are really simple. All you have to do is count the total number of letters or objects, all right, and you divide by any repeats. So in this case, we have 2 A's and 2 L's. So that's what we're going to do. We have 9 letters, so the order permutation of those 9 letters is 9 factorial, but we're dividing by the repeats. We can't distinguish. When we do this, we wind up with 90,720 different words that can be created from the word waterfall. Same idea with Mississippi. We have 11 total letters. There's 4 I's, there's 4 S's, and there's 2 P's. So if we divide out the repeats, the only distinguishable permutations that are possible with the word Mississippi are 34,650. The reason there's so many less is because we can't tell the difference between the S's, the I's, and the P's.